This is a NEET 2019 question from current electricity. The problem says the reading of ideal voltmeter in the circuit is. Here is a voltmeter. First of all, what do you mean by an ideal voltmeter? A voltmeter is said to be ideal when it has a resistance of infinite. So voltmeter is ideal means its resistance is infinite. Means what? Between these two, as the resistance is infinite, no current is passing. So the equivalent circuit is this: when the current comes from here, after reaching here, no current passes through this voltmeter, no significant current, because that has infinite resistance. All the current directly passes to 30 ohms. That means 20 and 30 are in series. Similarly, these 20 and 30 are also series. So what we can say, if voltmeter is ideal, the equivalent circuit will be 20 and 30, 50 on the top. The bottom also 30 and 20, 50. This 50 and 50 are in parallel. So R parallel equal to R1 R2 by R1 plus R2, that is 50 and 50 by 50 plus 50 is 100. 50 by 2 is 25 ohms. So the entire circuit has an equivalent resistance of 25 ohms. It is also given that the voltage source is 2 volts. So I can use a formula V equal to IR. So V is 2, I, R is 25. So the total current in the circuit is 2 by 25 amperes here. But this upper resistance and lower resistance is same. So this current is distributed as I1 and I2, as they are in parallel, upper part and lower part, that is this and this. V is same. So I is inversely proportional to R. But as R is same for each part, I is also same. So I1 equal to I2 equal to I by 2. This current is equally shared. That is 2 by 25 by 2. That is 1 by 25 ampere. So through each part, a current of 1 by 25 ampere is passing. Now you want the reading of that ideal voltmeter. Let me assume here voltage is V1, here voltage is V2, then you want V1 minus V2. But I don't know the voltage here. Let me call here that voltage as V. This voltage is also as V. So I can write further across the upper 20 ohms, that is across this 20 ohms, across 20 ohms of upper part, I am referring this one. I can write V minus V1, that is the voltage difference between them, is IR, that is I1 across 20 ohms, so the resistance is 20 ohms. So V minus V1 is I1 equal to 1 by 25 times of 20 ohms. Similarly, across the lower 30 ohms, across the lower 30 ohms, I can write again V minus V2, that is this and this can be further written like I2 and R, that R is 30 ohms. So V minus V2 is, I2 is also 1 by 25 of 30. Let me call this as equation number 1, this as equation number 2. Let's make 1 minus 2. What happens on the left hand side? V minus V1, or let us make 2 minus 1. So 2 is V minus V2 of the left hand side minus V minus V1. 30 by 25, this one, minus 20 by 25. So V minus V2 minus V minus of minus becomes plus V1 equal to 25 is the LCM, 30 minus 20 is 10. So this V and V will cancel. What is remaining is V1 minus V2 is 10 by 25, that is 2 by 5, that is 0.4 volts. That's the answer for the problem. That's how we have to solve the problem using the very basic aspects of equation, right? How does current shares in series and parallel? What happens to voltage? This basic information is sufficient to solve this problem. That's it. Thank you for watching.